So we have another question that is based on application of differentiation and integration on motion in a straight line. So it's a very, very simple and straightforward question. So we've been given displacement time relationship as t is equal to alpha x square plus beta x. For convenience, I've taken, I've inverted the equation the other way around. So we have alpha x square plus beta x is equal to t. Now differentiating with respect to time, first I'll just give you a brief outlook and then we'll go into the steps detail. So derivative of x square with respect to t is x into dx by dt, which is x into v, plus derivative of x is v. Now here we'll have to apply what? We'll have to apply the UV rule. So x into derivative of v is a, plus v into d by dt of x is v, which is v square, plus beta is equal to 1. So this equation 2x alpha to 2 alpha x v plus beta v is equal to 1 will be reused here. So 2 alpha x plus beta into v is equal to 1, and therefore we get a into 1 is equal to minus 2 alpha v cube. Pretty straightforward question. So this is just the gist of it. Now what we'll do is we try to understand this. Those who want it just can take down this, and if you want the differentiation in detail, you can keep watching. Okay, so yeah. So we have t is equal to alpha x square plus beta x, and d by dt of t will be equal to alpha into d by dt of x square plus beta into d by dt of x. What is d by dt of t? 1. What is d by dt of x square? Now that is where we need to understand a little bit of things. So say what is d by dt of, maybe I'll define this. What is d by dx of x square? It is 2x. But what is d by dy of x square? It would be 2x into dy by dx. Okay, into 2x into dy by dx. Similarly, d by dt of x square would be 2x into d by dt of x. What is d by dt of x? Rate of change of displacement with respect to time, which is velocity. So we reduce this equation as 1 is equal to 2 alpha vx into v plus beta v is equal plus beta into v. And we need this equation. So I just marked up in the box here. We need this equation later. So we'll differentiate this equation, equation again with respect to time t. So we have d by dt of 1 is equal to d by dt of 2 alpha xv plus d by dt of beta b. What is d by dt of 1? It's a constant, so that becomes 0. And then what we have is 2 alpha into d by dt of xv plus beta into d by dt of v. What is d by dt of v? It is acceleration a. What is d by dt of xv? First into derivative of second dy by dt plus second v into derivative of first, which is d by dt into x. What is dv by dt? Rate of change of velocity with respect to time is acceleration. What is d by dt of x? Rate of change of displacement with respect to time is velocity. So x into a, 2 alpha xa, v into v square into 2 alpha v square plus beta a. And what I'll do is, since the question contains only velocity in one RHS, I'll just transpose this. So we have minus 2 alpha v square is equal to 2 alpha x plus beta. I'll take this a common outside the bracket, so into a. Now I'll multiply this complete equation with v. So minus 2 alpha v square into v is equal to 2 alpha x plus beta into a into v. Now what is 2 alpha x plus beta into v? See, we have found out this value of 2 alpha x into beta plus v is equal to 1, right? So in this equation, the RHS 2 alpha x plus into beta into v, this much will be equal to 1. Therefore, this complete equation become minus 2 alpha v cube is equal to 2 alpha x plus beta into v will become 1 into a. Therefore, a is equal to minus 2 alpha v cube, which means the correct answer would be a is equal to minus 2 alpha v cube.